we're going to explore why the atomic mass of chlorine is a fraction and not a whole number. First, let's understand what atomic mass actually is. The atomic mass of an element is the weighted average mass of all naturally occurring isotopes of that element. It's measured in atomic mass units, or AMUs. But what are isotopes? Isotopes are atoms of the same element that have the same number of protons but different numbers of neutrons. For example, carbon-12 and carbon-14 are both isotopes of carbon. Carbon-12 has 6 protons and 6 neutrons, while carbon-14 has 6 protons but 8 neutrons. Now, let's look at chlorine specifically. Chlorine has an atomic mass of approximately 35.45 atomic mass units. If you look at a periodic table, you'll notice this isn't a whole number. Why is that? The answer lies in chlorine's isotopes. In nature, chlorine exists primarily as 2 isotopes, chlorine-35 and chlorine-37. Chlorine-35 has 17 protons and 18 neutrons, giving it an atomic mass of 35 AMU. Chlorine-37 has 17 protons and 20 neutrons, giving it an atomic mass of 37 AMU. So if chlorine has isotopes with masses of 35 and 37, why is the atomic mass 35.45? That's because the atomic mass is a weighted average based on the natural abundance of each isotope. In nature, about 75.77% of chlorine atoms are chlorine-35, and about 24.23% are chlorine-37. Let's calculate the weighted average to find the atomic mass of chlorine. The formula for the weighted average is the mass of each isotope multiplied by its fractional abundance, summed over all isotopes. So for chlorine, we multiply 35 by 0.7577 plus 37 multiplied by 0.2423. This gives us 35.45 AMU, which is the atomic mass of chlorine. Let's visualize this weighted average another way. Imagine we have 100 chlorine atoms. About 76 of them would be chlorine-35, and about 24 would be chlorine-37. If we were to put these on a balance scale and find the average, it would be 35.45 AMU per atom. Chlorine is not the only element with a fractional atomic mass. Many other elements like bromine, copper, and magnesium also have fractional atomic masses for the same reason. They exist as multiple isotopes in nature. So to summarize, the atomic mass of chlorine is a fraction because it's a weighted average of its naturally occurring isotopes, chlorine-35 and chlorine-37. Understanding isotopes and weighted averages helps us make sense of the periodic table and explains why many elements have fractional atomic masses. Thanks for watching.